I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are taking two questions based on continuity and differentiability of our functions. These two questions have been taken from past test papers. So first question is right before you. We have a piecewise function. Find if f of x is continuous and or differentiable for any value of k. And the second question is again another piecewise function where we have a quadratic function and a linear function. You need to find if f of x is continuous or differentiable at x equals to 2. So these are the two questions before us. You can always pause the video, answer these questions, and then look into my suggestions. Well, let's begin with the current question here. We're looking at a piecewise function f of x, which is x squared minus 6x plus 10 when x is greater than or equal to 2, and this is equal to 4 minus x when x is less than 2. We need to find if f of x is continuous and or differentiable at x equals to 2. So what is going to be your strategy? Well, clearly, let's first work on continuity. The function will be continuous if the limit for the function as we approach 2 is same from left side as well as right hand side. So that is the concept, right? Now this is a very important statement to write. Normally I've seen that in test paper students just substitute the value 2 and show that yes, it is continuous. It doesn't work that way, right? So limit when you are approaching from the left hand side is when you are looking at this particular linear function which is less than 2, right? So that will be 4 minus x, and we'll substitute x equals to 2 here, right? So where x is equals to 2. On the right hand side we have x squared minus 6x plus 10, and we'll also substitute x equals to 2 in this particular case. Now this format which I have written is kind of different since I use it, right? Not all books use it. Normally in the books you'll find, let's find out the limit when x is equal to 2, right? Or we can go from here to there, right? Now let's substitute 2 for x. What do we get? We get 4 minus 2, right? Which is indeed equals to 2, and that is on the left hand side. On the right hand side, when I substitute 2, I get 2 squared minus 6 times 2 plus 10, which is 4 minus 12 plus 10, right? Which is also equal to 2. Since we have shown that both the limits are equal, then the function is continuous, right? So since limit x approaches 2 from the left side for the function is equal to the limit when x approaches 2 from the right side of this particular function, they are equal. And they are also equal to the value of the function, right? So we are looking at this value because we know that f of 2 is also equal to 2 since the right hand side beyond 2 includes equal to also, right? So the function is continuous. So by definition, a function is continuous if the limit exists and limit is same as the value of the function, right? So let's make a note of this. So that means a limit exists and it is also equal to value of function. Makes sense, right? So we have shown that the function indeed is continuous. Right? Now let's look into the differentiability part. Right? So there are two parts, right? So we have shown that it is continuous at x equals to 2. So I hope this concept is absolutely clear. Feel free to write your comments, and in case you want to learn from me many strategies, you can always contact me on the given email address. Perfect. So let's move on and see part 2, where we are looking into differentiability of this particular function. So let's find the derivative of the function, right? So function is given to us. Let's write down the derivative. So derivative for x greater than or equal to 2 is 2x minus 6, right? This is for x greater than or equal to 2. And it is equal to minus 1 for x less than 2. Perfect. So what is the derivative of this when you are approaching 2 from left side and the right side? So let's substitute the value, right? So we get what? We get 2 times 2 minus 6, which basically equals to 4 minus 6 or minus 2, right? And on the right hand side, we know it is minus 1, right? So what we notice here is that when you're looking into the piece which is greater than or equal to 2, the slope of the tangent line is minus 2, right? And when you look at before 2, it is minus 1. So they do not match, right? Since we have seen that this for approaching from the left side is not equal to the derivative at 2 from the right hand side, so we say it is not differentiable. Make sense? So that I hope will help you to understand how do we solve such questions which involve both continuous and differentiable concepts, right? Now with that in mind, I have the question for you which you can treat as a test question, right? So here is the question, which is f of x is equal to x square minus k over x minus 1 when x is less than 1 and is equal to 2k square root of x when x is greater than or equal to 1. You have to comment on continuity and differentiability of this particular function. Now let's look into the continuity part, right? Now if you look at the rational function given to you, which is for x less than 1, you notice that it cannot be 1 because at 1 we have a vertical asymptote. Denominator will be 0. Now let's analyze this particular function, right? So when we are looking at x less than 1, we have x square minus k over x minus 1. Now, if I have k as 1, right? So if k equals to 1, then what happens? Then we get x square minus 1 over x minus 1, which could be written as x plus 1 times x minus 1 over x minus 1, correct? Now x minus 1 cancel, and this is equal to x plus 1, where x is not equal to minus 1, right? In the given condition, since x is less than 1, that is kind of true for k equals to 1. Does it make sense, right? So we understand one thing, that is to say that if k is equal to 1, then the function can be made continuous, right, at 1. You get the idea, right? It can be made continuous at 1. Otherwise, the left-hand side, you cannot really approach at that point, right? So we have a discontinuity there, correct? And the value will be infinitely large. There is a vertical asymptote. So let's see the value of the function at, if k is 1, what is the value of the function, right? So let's check the value of the function for k equals to 1, right? So we say if k equals to 1, then what is the limit of the function from left side and from the right side? Is that clear to you? So we can say limit when x approaches 1 from the left side will be what? So I'll substitute in the given expression 1, which is now for us, I could rewrite this as for k equals to 1, I'm rewriting, correct? The expression becomes x plus 1, right? When x is less than 1, right? And here, when k is 1, I could write this as 2 square root of x, correct? So we can write that the limit of this modified function, where k is equal to 1, right? So let's say f1x, right, should be equal to the limit when x approaches 1 from the right hand side, correct? Our modified function where k is 1. So if I substitute 1 here, then the left hand side will be 2, right? 1 plus 1, which is 2, right? And on the right hand side, I got 2 square root 1. So we say 2 is equal to 2. So we see that the function is continuous, right? So since both the limits are same, right? And then the value of the function is also 2, correct? Now f of 1 is what? For the modified function is also equal to 2, right? So we have the conditions met. Limit is equal to value of function, correct? Both are equal to 2. Is that clear to you? So we say that the function is continuous. Is that clear to you? So we got this part that the function is indeed continuous. Now let's look into the differentiability of this particular function, right? So I hope it is absolutely clear, right? You can always send an email on the address given to learn more. Now let's continue with the differentiability part. So let's write down the derivative of the function here. So what is the derivative? Now for k equals to 1, we wrote that the function reduces to, so let me first write the function itself for k equals to 1, then we'll write the derivative. Is that clear to you, right? So it is x plus 1, and here we have 2 square root x, correct? Now, from here, let me complete this, right? This is for k equals to 1, right? So now, if I write the derivative of the function in both the intervals, then we get what? We get 1 when x is less than 1, and this derivative is 1 over square root of x, correct? For x greater than or equal to 1. Now look here. At x equals to 1, both are 1, right? So we see that the derivative at 1 is equal to what? Is equal to 1 from both the sides, correct? That means the gradient, the slope of the tangent line on this particular function is exactly 1, right? Makes sense, right? So if you visualize it, which you can very easily, you see one function which is x plus 1 is a straight line when x is less than 1 is something like this. X plus 1, right? So kind of like this, right? And you will notice that if I sketch the square root function, it will go like this, right? So you see it is tangent to the square root function. You get the idea? So this is your 2 square root x. And at that point, we see that they are continuous. And since it is a tangent for both at the common point, the function is also differentiable. Makes sense, right? And therefore, in this case, we see that the function is both continuous and differentiable for k equals to 1. Make sense? So that is how we are going to answer this particular question. I hope you understand the concept. A very important concept, derivative of functions test question. And with this, you can always gain confidence, understand this strategy and apply for getting much better marks. I hope it makes sense. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. Thank you.